This lecture is on the derivative rules with natural functions part 2. So today we're going to take a look at how to differentiate the natural logarithm. So last time, well, let's recap a little bit. So now I know how to take derivatives of constants. Derivative of constant is 0. I know how to take derivatives of powers of x. Derivative of power of x is n x to the n minus 1. And I now know how to take derivatives of e to the x. The derivative of e to the x is just e to the x. And so today, I want to learn how to take the derivative of the function ln of x. It will turn out the derivative of ln of x is 1 over x. And so the way this works, let's write down the rule here. So this rule is the natural rule, and we'll call it part 2. Oops, well, let's copy it down. So the natural rule part 2, and it says d dx, the derivative with respect to x of ln of x, is just equal to 1 over x. And we'll talk a little later in the semester why this is true, but for now we can write down the saying the derivative of ln of x is 1 over x. Or you can say the derivative of ln is 1 over. So the derivative of ln of x is 1 over x. So that's sort of the saying I remember. Later on, I'll say the derivative e is e again, and I'll say the derivative ln is just 1 over when we apply it to the chain rule. So we want to take a look at a couple of examples here. So let's take a look at example 1. And on this example, what we have is f of x equal to e to the 3x minus ln of x. And if I want to take the derivative, f prime of x is equal to, now the derivative of e is just e again, so the derivative outside is e to the 3x, times the derivative of the inside, the derivative of 3x is just 3, minus, now I apply my new rule, the derivative of ln is 1 over x. And so this is equal to 3 times e to the 3x minus 1 over x. So a nice easy rule. The next question, next example we want to do involve product and quotient rules. So example 2. And so let's look at part A. Part A says g of x equal to x times ln of x. And so hopefully when you see these, you see there's two functions. There's a first function, and there's a second function. And we're multiplying, so we're going to use the product rule. And so to find the derivative, I simply say g prime of x is equal to the derivative of the first, which is 1, times the second, ln of x, plus the first, which is an x, times the derivative of the second. Now the derivative of ln of x is the new rule we learned today, which is 1 over x. And so this is equal to 1 times ln of x, it's just ln of x, plus, and then right here, since you have an x on top and an x on bottom, these are going to cancel, and you're going to be left with just a 1. So ln of x plus 1. On part B, we have h of x equal to x squared divided by ln of x. So the last problem was a quotient rule. well, it was a product rule, so this problem will be a quotient rule. So to take the derivative of this one, we'll have to identify our high function and our low function and do low d high minus high d low all over low squared, and away we go. Let me clear this off here. Alright, so to find this, h prime of x is equal to my low function, which is ln of x, times the derivative of my high function, which is a 2x, derivative of x squared is 2x, minus my high function, which is x squared, times the derivative of my low function, so this is, again, this is the new rule, derivative of ln of x is 1 over x. And this is all divided by low squared. So ln of x, quantity squared. And so that's equal to, I have 2x ln of x minus, and I'm going to get some cancellation here, I have x squared on top and x on the bottom, so I'll be left with 1x, all divided by ln of x quantity squared. And then I can factor out what they have in common on top, so they have an x in common, so this is going to be equal to then x times 2 ln of x minus 1, all divided by ln of x quantity squared. And so this is my answer for part B. Alright, so let's look at the next example. So in the next example, we're going to start using the chain rule and then start using the chain rule in combination with the product and quotient rule. So we start right here with f of x. So example 3. Part A, we have f of x equal to, and we have ln of x squared plus 3x minus 7. And we want to take the derivative, so we want to find f prime of x. And so notice first we have an inside and an outside function. So here's our inside function. And then our outside function is the ln function. And we're going to use a chain rule. The chain rule says derivative of the outside, so derivative ln is 1 over. So we have 1 over x squared plus 3x minus 7 times the derivative of the inside, which is a 2x plus 3. And so this is equal to 2x plus 3 on top. And then on bottom we have an x squared plus 3x minus 7. The next problem right here on part B, let's copy it down. So we have g of x equal to e to the 7x ln of 3x. And now if you think about this, which rule are you going to apply first? And you have all kinds of choices. Let's see, you could apply the first natural function rule to this e, but of course that won't involve this ln of 3x. You could apply the second natural function, second natural rule to ln of 3x, but of course that won't involve the e. So you want to apply the rule that involves everything. So what you have here is the first function, e to the 7x, times the second function, which is this ln of 3x, and then it becomes obvious, since you're multiplying, you're going to use the product rule. And so let's take the derivative of this. And so what we have is g prime of x is equal to the derivative first, which is just a e, derivative of e is e, so e to the 7x is a chain rule, times derivative of the inside, so times the 7, and then times the second function, ln of 3x, plus, again, this is a product rule we're using, the first function, e to the 7x. Let's delete that. So I have e to the 7x times the second function. So now the derivative of ln is 1 over. So 1 over 3x times derivative of its inside. Because again, this is a chain rule here. You have inside function and outside function. So derivative of the outside is 1 over 3x times derivative of the inside, which is a 3. And so this is equal to, let's clean it up. So I have 7 e to the 7x ln of 3x plus these 3's are going to cancel, and so I'm left with e to the 7x all divided by x. Okay, and if you want here, you can factor out what they have in common. So they don't have any numbers in common, but they do have a e to the 7x in common. So I could pull out this e to the 7x and get something plus something. And the first something, there's a 7 ln of 3x plus a 1 over x. And so here's my answer. Okay, let's take a look at the next question. Part C. Now when I look at this, I have a high function and a low function. And that rule would involve everything. So which rule involves the high function and low function? Hopefully you're thinking the quotient rule. Not the product rule, right? I do have an x times e to the x, so I will use a product rule eventually, but I don't want to start out with that because that just involves the high function here. So let's copy this down. Part C, I have h of x equal to x e to the x all divided by ln of x. And this is my high. This is my low, and the derivative, the quotient rule says low d high minus high d low all over low squared, and away we go. So h prime of x, what is it equal to? Well, I copy down my low, so my low is ln of x. And now I have to take the derivative of my high function. Now notice my high function, to take a derivative of this, I have x times e to the x. So I'm going to have to use a product rule on it. And so I'm going to get this all times 1, that's derivative of the first, times the second, plus the first, times the derivative of the second, so that's just an e to the x, minus my high function, which is x e to the x, and then times the derivative of my low function. Now, the derivative of my low function is this ln of x, and its derivative is just 1 over x. That's the new rule we learned today. And then this is all divided by low squared, so ln of x quantity squared. And so what can we do here? Well, we can multiply through by the ln of x in the first term, so I'm going to get an e to the x ln of x plus an x e to the x ln of x, and then just minus a single e to the x, because these x's, let me switch colors here, these x's right here will cancel, an x on top and an x on bottom. And this is all over the low squared, so all over ln of x, quantity squared. If you want, I can factor out what they have in common. And what do they have in common? Well, if you look here, you see they have, this has an e to the x, this has an e to the x, and this has an e to the x. So I should be able to factor out an e to the x. And if I do that, I just copy down what's not written in yellow, minus 1, all divided by ln of x, quantity squared. And that's my answer. So the last one on this example is right here, part D, and if you look at it, you're definitely going to have to use a chain rule here. You have x plus 2 divided by x minus 2, but you do not want, not a chain rule, quotient rule, x plus 2 divided by x minus 2, but you do not want to start with the quotient rule because it doesn't involve the ln. So we're actually going to start with a new rule we learned today. So on part D, so this is a chain rule with a quotient rule inside it, really. I have y equal to ln of x plus 2 divided by x minus 2. And to find y prime, instead of using the quotient rule, which does involve the inside, I'm going to use basically a chain rule, because if you look at this, you have an inside function here, and then the ln function is my outside function. If you say it, I mean, you can see it's ln of this inside function, ln of x plus 2 divided by x minus 1. And so the chain rule says derive the outside, so derive ln's 1 over, so I have 1 over x plus 2 divided by x minus 2 times derive the inside. So derive the inside, this is going to be a quotient rule. So I have a high function and a low function, and so I have low d high, so x minus 2. D high, derive x plus 2 is just 1, plus 0, but I just write 1, minus my high function, x plus 2. And the derivative of my low function is also just 1. And then all divided by low squared. So x minus 2 quantity squared. And so then this is equal to, well, let's simplify this. When you divide by a fraction, it's the same as multiplying by its reciprocal, so you just flip it. So I get an x minus 2 on top, divided by x plus 2. And then all times, up here on top, let me switch colors, I have x minus 2 minus the quantity x plus 2. And so what's going to happen is that x minus x is going to cancel. I have negative 2 minus 2, which is a minus 4. So I'm going to have a minus 4 on top, and then an x minus 2 quantity squared on the bottom. And so now what's going to happen is that this x minus 2 on the bottom is going to cancel with one of these. And so this is going to equal minus 4 divided by x plus 2. Let me erase that. So x plus 2 here. And this is going to be all times on the bottom, x minus 2. And you can leave it like this, or I would probably write this as minus 4. And since this is the difference of 2 squares, x squared minus 4, I'd write it like that. Because it's x plus 2 times x minus 2, so the middle terms cancel. Okay, the last example we want to take a look at involves logarithmic functions in general. So what do we do with logarithmic functions in general? So let's first make sure we understand, what is a logarithmic function in general. So we have this idea of a logarithmic function. And so to understand logarithmic functions, we have to first understand exponential functions. And so the idea goes back to, let's pretend this is our domain. So we use a bunch of numbers here. And it's the domain for the function, let's say 3 to the x. And the idea is if you plug in 2, 3 to the x is going to take this to 3 squared. So over here you have its range of this function. Now you would like to be able to go back the other way. So start over here, find a function where you plug 3 squared into it, you get back 2. And that's the function log base 3 of x. So if I plug this in for x right here, I'll get back 2. So that's what the log base 3 function really is. It's the inverse of the exponential function 3 to the x. And what we would like to find out is how can we take the derivative of log base 3 of x? What is this going to be? I know that the derivative ln of x is 1 over x. Can I somehow use this bit of knowledge to figure out what the log base 3 of x actually is? And it turns out we can. And the reason we can is because we know that the log base 3 of x can be written as ln of x over ln of 3. And now I can take the derivative of ln of x divided by ln of 3. Remember, divided by ln of 3, that's just a constant. So what you're going to get is basically 1 over ln of 3. Now the constant just stays, times the derivative of ln of x, which is 1 over x. And so this derivative will just be 1 over ln of 3 times 1 over x. Or in some textbooks, they'll write this as 1 over x ln of 3. And this is going to be then we can actually make a general rule if you like. So let's go down here. Let me just get this going. Let's scroll down a bit. So I can make a general rule. I now know from the last lecture that for d dx of a to the x, this was equal to what? A to the x ln of a. That's what we found last time. There's a general rule for any exponential function. And now I can use what I found above, d dx, for log of any base. And usually we write base b. For any base b is equal to, and I look up here, and for 3, it was 1 over x ln of 3, so I'm guessing it's 1 over x ln of b. And so there's the general rule for any logarithmic function base b if you want to find the derivative. So let's take a look at an example using this. And so here we have log base 3 of x, and we want to find the derivative. So example 4, part A. So let's copy it down. F of x is equal to x squared log base 3 of x. And before I find its derivative, let's rewrite this as x squared ln of x divided by ln of 3. Remember, I know I memorize this basic identity that log base b of x is equal to ln of x divided by ln of b. This is how we find logs of different bases with our calculator. You convert them to natural logs. And so if you look at this, what you're going to see here, and I can even rewrite this if you like, I have x squared times 1 over ln of 3. This is times then ln of x. And this is going to be a product rule, and I have to identify my first and second. So I'm going to let this be my first function, and then this be my second function. And so then I follow the product rule. F prime of x is equal to the derivative of the first, which is a 2x, times the second, so 1 over ln of 3, times ln of x, plus the first function, which is just x squared, times the derivative of the second. Now the derivative of the second function is just a constant times a function, so the derivative is just a constant. So 1 over ln of 3 times the derivative of ln of x. And derivative of ln of x, which we learned just today, was 1 over x. And so this is equal to There are a couple things to keep in mind here. This expression right here, remember, is the same thing as log base 3 of x. And so what I'm going to write here is that this is 2x log base 3 of x plus, and then these x's are going to cancel, or at least one of them on the bottom will cancel with one of these, plus x over ln of 3. And I guess you could leave it like this if you really want to. I could also, I guess, factor out the x too. I could factor out this x. So I have 2 log base 3 of x plus, what do I have here? I have ln 1 over ln of 3. So let me make some more room here. A little more room. And so I have 1 divided by ln of 3. So that wasn't so bad. Let's take a look at part B. So on part B, I have g of x equal to 2 log of x squared plus 1. Now what makes this problem a little bit different is that there's no number down here. Now when there's no number down here, it's implied that there's really a 10. And so I can rewrite this as 2 ln of x squared plus 1 divided by ln of 10. And I can rearrange the terms a little bit if you like, and I can just put the constant stuff together. So I have 2 divided by ln of 10 times ln of x squared plus 1. Now I haven't taken the derivative at all, but I can, it's in the right form. So if I want to find g prime of x, what I need to realize is all I have here is a constant times a function. And the derivative of a constant times a function is just the constant 2 ln of 10 times the derivative of the function. And so when you look at this, you have an inside and outside. So here's my inside function. Here's my outside function. And so the derivative of the outside is 1 over. So I have 1 over x squared plus 1 times the derivative of the inside, which is a 2x, because the derivative of the inside is x squared plus 1. So this derivative is just 2x plus 0. And so this is equal to, let's write 4x on top, 2 times 2x, divided by, and let's just write an x squared plus 1 on the bottom. Extend that line a little bit with an ln of 10 to the right. And so there's my answer.